Do you want to quickly and easily connect multiple pieces of data to a single application? Today, we are going to go over the basics of data binding using Framework Markup Language, a powerful, cross-platform capable approach to building a unified app without having to touch your databases. We're going to cover two aspects of data binding: connecting to widget attributes and connecting to data returned from data source widgets. These widgets can include hardware data sources such as NFC, RFID tags, and camera data such as optical character recognition or simply images. This also can include network data returned from a REST API, WebSocket, or any other network protocol. You can check out our other videos for tutorials on linking NFC, RFID, and laser barcode data, as well as more over at our YouTube. Data binding is quite simple in FML. Data is built dynamically to bind to, updating the UI as it changes. This eliminates the need for complex state management solutions to drive your UI. Let's start with the notation. Bound data is always denoted by curly braces. Inside the curly braces, there are three main parts to data binding when interacting with widgets. These are the ID, dot, the attribute, and the offset, which is denoted with a colon. The ID will always refer to a widget and will automatically assume that the attribute is the widget's value when referring. If we take this text and add a select widget, adding an ID to the select, we can see that by simply binding this text to cell 1, which is the value of the select, we can see running our mobile application that both the 1 in the select and the 1 as the value of the text are updated as we update the value of the select. Data binding isn't simply used to display values, but also drive values. You can show that by using margin on the text. Let's take the data binding of cell 1 and bind it to the margin value on the text. This is going to increase or decrease the margin as we select each option. Using something more noticeable, let's go 10 and let's go. Now we come back into our application. As you can see here, it reflects both the value numerically and the margin applied to the text widget. We now pick 20, and this is even further. As you can see, data binding and its listeners are a very powerful tool to run any portion of your application. You can also bind to any attribute that a widget contains. In this case, select is a form field widget. As you can see, select inherits from form field, and form field contains the field dirty. Dirty is a bindable attribute, not a settable attribute. That means when the field has been touched, dirty will be true. We can look at the binding to this by changing our text. Let's leave a margin of 10, and we're going to bind to the ID dot the attribute. And then in this case, the attribute is dirty. We can see that as we open the select and change our selection, the value then changes to true. Changing our selection back maintains this true value because the field has not been committed and therefore is still dirty. Direct widget and attribute binding is great to run UI and pass data around, but a very powerful and very useful aspect of Framework Markup Language is binding to created data from different data sources. Let's take a look at the REST API using a GET call. We're simply going to add the GET widget. This handles all of your creation and deserialization of your data. Let's give it an ID of GET1. And let's give it a URL. That URL is going to point us to a local file. Remember, your URL can be fully qualified or localized. This data is going to be featured in our upcoming video of building a jet tracking dashboard. Remember to set up your notifications and subscribe to get instant access to that video as soon as it's released next week. Framework Markup Language supports both JSON and XML formats. And we can see here that we've got nested JSON data. This nested data can be traversed using further dot notation. You can see here, as a brief preview of our Jet dashboard, that these gets are using fully qualified domain names to reach out to different APIs to unify multiple APIs into one application. We can use both the web portal and the application to examine this GET call. We're going to first bind to get1.attribute, and in this case, the attribute is going to be data dot the field of the data. And let's display the first and last name of each user in the data. First name, last name. Instantly updating, we see the user is Elon Musk. If we take a look at our web portal, here we can use our network tools to examine the get call. Using the network tools, we see the response, the headers, and the preview. And you can see we have multiple rows of JSON data. So what if we want to access the second row? Well, that's easy. We simply use the offset. Get1.data offset 1, and that will give us our second. And let's leave the last name the same. We can now see that the user is Bill Musk. In this case, we're going to do data:4 first name, data:4 jets, and let's say the second jet, so jets:1, and we can further traverse down using dot notation. And let's bind to something that's obvious. So in this case, we're going to bind to the model, as each model is different. We have our 750, 7200, and we have our 750. So we should get our 750, and we should get Donald Trump. And we'll bind to the model, maintaining the lowercase m, and we see the user is Donald with the jet 750. As you can see, these trees can be as deep or as shallow as you'd like, containing as much data as you'd like, and you can easily traverse this data. What if we want to dynamically build data from all of these? It wouldn't be very useful to programmatically add each offset. That's where data UI widgets come in. In this case, we're going to use the data UI widget list. Data UI widgets take an ID of a data source and allow iteration and individual scope for each row of the data source at the root. In this case, we don't have to give the get a root because the root is the initial data source level. If we wanted it to start somewhere deeper, such as the jet root, we would have to describe that root using dot notation, similar to how you would bind to it. So let's replace this select, which is also a data UI widget, with list. List, rather than option, will take an item. This item is going to be what reiterates each time a new data row is added to our data source of get1. In order to add this, we need to give it a data equals, and that data equals will be get1, tying this list to this get call. This is where we get slightly different binding behavior because we're working within a scoped item. In this item, let's add a text and let's give it a value. Because we want to work within the scope of the list's data rather than binding directly to the data source, we are simply going to say data dot, referring to this list's data, and let's say first name. This will create as many items as there are data rows, binding the first name in each individual item's data to each row. We can now see that we have every single first name. And down here we can see our initial binding. You can also bind to the data source from inside the list without having to bind to the scope. This is simply done the exact same way as you would bind outside of the list. Let's give each item a little bit of padding, and we can see that each item has its own binding, but each item also has the initial binding that's scoped to the data source itself rather than to each item's data. This data, like any other binding, can drive the look of the list. Each data-driven UI widget further allows you to narrow down data by assigning this data to each individual item. Items like list are selectable. Let's add a box around everything and give each item an ID. In this case, the ID is going to be user item. We're going to bind to user item, which is the ID of the item, dot selected. And again, we see when you select an item, it lights up. How do we drive data from the selected item? Well, in this case, we're just going to refer to the list. But because we don't want the data, we want the selected data, we're going to say cell1.selected, which is the selected data, .jet. And let's again call the model of the jet. We see right now the jet is blank. We can select a person, it highlights the selected box, and we can see what their jet is. Now, to take this one step further, we're going to use the base level data source widget, which is simply data. We're going to give it an ID of DS1. We're going to give it a value of cell1.selected, which is the data of each selected item in the list. And finally, we're going to give it a root of jets, because for the selected data, we want to use the iterable jets. Using the select we had before, we're going to add an option, and we're going to supply the select with data of DS1. The option's value is then going to be the value scoped to DS1, which is data.model. Selecting a single person, we can see that we have the jet 680A. If we select somebody with multiple jets, we can see the list automatically rebuilds with his multiple jets. There are multiple attributes to control this appearance, such as add empty, which will remove this item from the list. If we don't want an empty option, we can see it's easily updated as we select the options. And that's it for basic data binding with Framework Markup Language. As you can see, it's an incredibly powerful tool, allowing you to bind to widgets and their attributes, create and drive UI and other operations, scope widgets using the data syntax, and bind to widgets using the id.attribute or id.data.field. You can also traverse through multiple levels of any tree structured data in both JSON or XML. And there you have it. That was the basics of Framework Markup Language and what can be done with basic data binding. Framework Markup Language automatically interprets data as it comes in, allowing you to focus more time on building your cross-platform application. If you have any comments, questions, or would like to see anything in the future, let us know in the comments below. For the Jet Tracking Dashboard, like and subscribe, as well as turn on notifications to see how we track each of these individuals' jets using Framework Markup Language in less than 400 lines.